Espinosa, and I'm going to talk about the boost converter system. In simple words, boost converter systems work if we giving input DC voltage. At the output, we're going to have our DC voltage with the same polarity but with a higher magnitude. Here we have the topology of a typical boost converter system. Here we have the input voltage, the inductor, the transistor, the pulse width regulation controls, which determine the zone where the transistor is going to work. Also, we have the diode, the capacitor, a load, and the output voltage. The operation cycle of the boost converter can be divided into little cycles. One where the transistor is working in the saturation zone, and other when the transistor is working in the cutoff zone. The transistor in the saturation zone can be replaced with a switch in the on position, and the transistor in the cutoff zone can be replaced with a switch in the off position to simplify the analyze. In the case where the switch is on, we have two networks. One where the inductor is charging with the input voltage, working like a passive element, and other network where the capacitor is giving his energy to the load, acting like a passive element. And when the switch is off, we have only one network where the inductor is going to discharge, giving his energy to the load and to the capacitor. Here the capacitor is going to charge with this energy, and the cycle repeats, giving the inductor charging again and the capacitor discharging again, repeating the cycle once again. One important fact is the current who goes through the inductor has linear behavior. We can see this with the theory. If we use the equation that describes the voltage in the inductor, and we got the equation that describes the current, we see that the current increases linearly with a slope that depends on the voltage of the inductor and its inductance, seeing a kind of Ohm's law. In a real, we can see that the inductor increases its current really high, so in the boost converter system, this switch between on and off have to be real quick to give this energy one.
Hello, my name is Jaime Zapata. I'm going to talk about the advantages of a boost converter. It has higher efficiency compared to the buck-boost converters and wider range of applications, because the boost converter turns a DC signal to a higher level, and the buck-boost converter does it to a lower level. It also has an easier control system than the boost converter, because it has a positive voltage output. And finally, it has an easy circuit arrangement, because the ground of the switch is the same as the DC input signal. I am going to talk also about the applications. It is often used in photovoltaic systems, because the boost converter it transforms the voltage input of the solar panel, because the solar panel voltage input can vary with different weather conditions. And it can be also used in the regenerative braking of DC motors. Here can we see the regenerative braking schematic, and it has some similarities. The motor windings are used as the inductors in the boost converter. These three MOSFETs are used as the diodes in the boost converter, and the three other MOSFETs are used as a switch. And finally, they can also be found in personal electronics, because boost converters are used in power battery applications where the space is constrained and we needed to put more batteries in them to achieve higher voltages.